This video is going to cover some of the key concepts from Chapter 2 in Siegel. So, Chapter 2 lays out what I call the fundamental question of statistics. So, the fundamental question of statistics is defined by a lot of these terms on this slide. So, really, what statistics is about is as follows. We're studying a certain set of units. So the unit is a generic term for the entity that we're studying. Let me make this a little bit more concrete. If I were doing a public opinion poll, what I would be studying would be the opinions of individuals. So my unit of analysis would then be an individual. Sometimes I want to know whether promotions, an in-store promotion works in various stores. So what I might do is an experiment where certain stores have have the in-store display, others don't. In that case, my unit of analysis is going to be the store. When I'm a direct marketer and I send a catalog to someone. The unit of analysis is really the household, and that if LL Bean sends a catalog to my wife, it's sitting around my house, and if I place an order from something in that catalog, that really counts as an order for the household. So what LL Bean really cares about is households, and those that would be the unit of analysis in that case. Now, the collection of all units that we care about has two different names, and the two names are completely synonymous. The two names are population and universe. So marketing research people tend to use the word universe. People with more statistical backgrounds tend to use the word population, but they mean the same thing. So the population is just everybody in all the units that are in your defined target. So I'm using that word target because in marketing we often segment a market and then target one of the segments, and we talk about a target segment. Well, that target segment usually corresponds to our population of trying to get to know that segment. Okay, now the fundamental question of statistics is as follows. Among the units in this population, there's something that I want to know, and that something is called a parameter. So let me give you a little example. If this were a public opinion poll, I might want to know the percentage of all adults in the United States. So in this case, adults are my unit. All adults in the US make up my population or universe. And I might want to know the percentage of all adults who favor some policy. Okay, so the percent who favor that policy is the parameter. So it's just a numerical fact about the population. If I have some target segment and I'm going to do a concept test, so I show people my concept, and maybe I'm interested in purchase intent then. So the parameter in that case would be the percentage of people in my target segment who intend to buy this product. So it's the percent of people in the population who intend to buy it. So that's an example of a parameter. Now, how do we learn what this parameter is? And the answer is we're going to do some sort of survey. So surveys are just a data collection method. Now, there are two types of surveys in statistics. One is called a census. So with a census, we go out and we gather information from every sampling unit in the population. Now, once I've gathered information about every unit in the population, then I compute the parameter directly. So a classic example of a census would be an election. So if I want to know the percentage of people who are going to vote for a particular candidate, on election day, I do a complete census. Everybody who votes, I know about, and then I compute the percentage of them who vote for candidate X. All right, so a census is where you measure every unit in the population. You know, the population in that example I just gave would be the voting public. You know, if you don't vote, you're not part of the population. The problem with the census is that it's really expensive. So very often our populations are quite large. So it's prohibitively expensive to do censuses in most instances. So in that case, what we're going to do is a different type of survey. Remember I said there are two types of surveys, censuses. The other is a sample. So a sample is where you gather some subset of the units and you take the measurements on just that subset. Now from that subset of units, I can compute something called a statistic. So a statistic is some numerical fact, not about the population, but about the sample. And it is this statistic that approximates the parameter. So much of statistics concerns itself with, what's a good way to sample data? So how do I get the data? What is the best way to compute a statistic to estimate the parameter? And then how good is my statistic? So do I think I'm close to the parameter? Is my statistic close, or is it far away? And that last question, I think, is one of the most profound questions that we're going to answer in this whole course. We're going to say with great certainty how close we are to the parameter later on in this course. So at this point, there's a your turn. So either you do this as a class exercise or on a discussion board. What I want you to do is to think about a poll. And this poll is going to determine who's going to win an election next week. And what I'd like for you to do is to think very carefully about what all these terms are. So what is the unit? What precisely is the population that we're studying? What precisely is the parameter? How are we going to gather the information? And then what specifically is the statistic? So we'll have that as a discussion board or class discussion. Now, for those of you who've had some statistics before, the discussion that we've just had may ring some bells. And what I've done on this next page is to list out all of the statistics that you're going to cover in Siegel, statistics and parameters, that is. I've also given you the symbols. Now, if you've not had statistics before, don't worry about it. We'll introduce these things in a little bit. But just to kind of connect with what you probably have done in the past, one common parameter is a mean. We're going to use the Greek letter mu to denote the parameter x bar for the statistic. We're going to study a lot of proportions or percents. Pi will be the parameter, p will be the statistic. We're going to study standard deviation. So sigma is the parameter, s is the statistic, and so forth. One other word on notation. So a lot of people, I think, get hung up because of the terms in this class. So it's really important to get these terms right. We're going to use population and sample as prefixes, if you will, before the names of these things. So for example, mu is going to be called the population mean. So mu is the mean, but it's not any old mean, it's the population mean. So the parameter is the population mean, pi is the population percent, x bar is the sample mean, and p is going to be the sample percent. Just emphasizing that the statistic is coming from the sample, the parameter is always coming from the population. Another topic in Chapter 2 is on types of variables. So this is a pretty important set of vocabulary to have. So there are a lot of different variables that we'll encounter in our work. So a variable would be something like a person's age, person's income, person's race, person's purchase intent. And what statisticians have done is to form different types of these variables. Now, the reason they've done this is because certain analysis methods will work with certain types of variables, but not with others. So it's completely analogous to, say, a carpenter. So, a carpenter has screws and nails. And so a screw is something that has threads and some sort of slit on the top of the head, where a nail is this pointy thing that doesn't have that slit. Now, it's kind of a useful distinction between screws and nails because in the carpenter's toolbox, there's screwdrivers and there are hammers. So if you have a nail, you're going to use the hammer tool as opposed to a screwdriver. Screwdrivers don't work very well on nails. Likewise, if you have a screw, then you want to use a screwdriver. So there's this correspondence between the type of variable and the type of statistical tool, just as there's a correspondence between the type of pointy object and the tool that is used to sync that object. All right, so broadly speaking, variables fall into two categories. So there are categorical variables and numerical variables. So this is a fairly loose definition, but categorical variables will take non-numerical values such as race, brand choice, marital status, postal codes, whereas numerical values we're going to be sticking on a continuum. So they're measured with numbers, i.e. you can put this on a number line. So things like age, income, sales, number of children are all measured with numbers. Now within categorical variables, there are two subcategories. One is nominal. So nominal variables have no ordering, whereas ordinal variables have an ordering. So the way I like to think of this is you can ask the greater than question with ordinal variables. So if you have two values, with ordinal variables it makes sense to ask the question, is one value greater than the other? It makes absolutely no sense to ask the greater than question of a nominal level variable. So let me give you an example. What is your favorite flavor of yogurt? And the responses could be strawberry, peach, blueberry, or plain. All right, well, it makes absolutely no sense to say that blueberry is greater than strawberry. They're just discrete categories and they have no ordering. Likewise, if I ask you what is your race or your marital status, I can't really say that divorced is greater than widowed, or that Hispanic is greater than Caucasian. And those questions just have no meaning, which will get us to which statistics are reasonable. So things like the median require us to sort the data from smallest to largest. So we need ordinal data in order to do that sorting, because for me to sort, I have to answer the greater than question. Likewise, within numerical variables, there are two subclasses, interval and ratio. So remember, numerical variables are variables where you can stick them on a number line. The difference between interval and ratio has to do with the existence of a meaningful zero. So what is a meaningful zero? A meaningful zero is when the value 0 means nothing. All right, so the value 0 means nothing. There's nothing there. All right, so 0 kids means I don't have any kids. 0 profit means that my profits are 0. Let me give you a real quick example of this to make this real clear. The classic example of a scale that is interval but not ratio is temperature, especially measured degrees Fahrenheit or degrees Celsius. All right, so why is this interval but not ratio? Well, in the case of both Celsius and Fahrenheit, the value 0 does not mean nothing. So In Celsius, 0 just means the freezing point of water. It doesn't mean that there is no temperature. In Fahrenheit, 0 just means really cold, but doesn't mean that it can't get colder than really cold. Now, I said that these these scales map on to what you can do with a variable. So let me give you a little more subtle example of doing something nonsensical with the variable. So I said, earlier, it makes no sense to use a hammer on a screw, and it makes absolutely no sense to compute the median flavor of yogurt. Here's a little more subtle example. Very often we want to compute ratios of variables. So one instance of this is in a percent change. So let's see what happens if we try to compute a percent change on an interval but not ratio level scale. Let's say that yesterday was 50 degrees Fahrenheit, and today is much nicer, it's 68 degrees Fahrenheit. So it doesn't make sense to talk about how much warmer it is today versus yesterday in terms of a percent change. Well, let's compute one. So 68 minus 50 divided by 50 is 36%. So it seems that today is 36% warmer than yesterday. But that statement is really nonsense. Let's convert these temperatures to Celsius and see what happens. Okay, so 50 degrees Fahrenheit happens to be 10 degrees Celsius, 68 is 20. So using the Celsius scale, we get to 100% warmer. So today is 100% warmer than yesterday. And of course, this is just complete nonsense because Fahrenheit said it was 36. The problem here is that you're not allowed to compute a percent change unless 0 means the absence of anything. That means that you can't shift it around. So the basic problem here is we're shifting these temperatures around with the 0, and that's why you get this kind of crazy result where it can't be both 36 and 100% warmer at the same time. All right, so a little bit more on that. With nominal level data, for example, about the only thing you can do is compute modes. To summarize it, you can compute percentages, so I can say 30% of the population prefers strawberry yogurt. That's fine, and I can talk about modes, but that's about it. With ordinal, I can continue to talk about modes, but I can also use the median. So with the median, for those of you, we'll define means and medians and modes in about a week. But the median just says sort the data from smallest to largest and give me the middle person. That's the median. Well, I can definitely sort values from smallest to largest if I have an ordinal scale, since I can answer the greater than question. When it comes to interval level data, we can do modes, medians, means. We'll talk about standard deviations next week. We can do all these things. The only thing we can't do are things like percent changes, as we just saw. There's another statistic that you probably have not seen in a previous stats class, but you will see, I guess, next week, which is the coefficient of variation. So that also involves a ratio. And so these are just some of the basic statistical tools and how they get mapped to these types. Down below, you have a preview of something we're going to talk about in 2 weeks, which are methods of studying relationships. And so all these tools depend on the measurement levels. So this section of the chapter is quite important. Let's go back, and I want to finish up a few other terms that we're going to be using from time to time in this course. So the first additional term is called dichotomous. So dichotomous variables are variables that only take 2 values. So these are especially common in marketing. Anytime you have a yes/no variable, we call it dichotomous or binary if you want to use a fancy term. Another example would be your gender. Are you male or female? I know gender is sometimes at the household level, male, female, or both if it's a married household, but I'm talking about an individual unit now. So there are many examples of this. If you have a banner ad and people either click on it or they don't, so click or not. If you send out a mail piece and people either respond or they don't. Do you recall seeing my ad? Yes or no? Do you intend to buy this? Yes or no? So dichotomous variables are extremely common all over marketing. Another variable that we'll encounter quite often and has some special properties is called a count variable. So count variables are variables that take only values 0, 1, 2, 3, 4, dot, dot, dot. Okay, so only the counting numbers. And these variables are common, so the number of kids. Frequency is a very important variable in database marketing. Frequency is the number of times that you've purchased in the past. So we're going to have special methods for count variables. There's something called the Poisson distribution that will often be used in modeling count variables. Another variable that you've probably not encountered before, at least name that you've not encountered before, is an amount. So an amount is a quantity of something. So the way to think about an amount is that it takes values that are 0 or positive real numbers. So it's a quantity of something. You can't really have a negative quantity of something. So you can think about my weight as being an amount. My age is an amount. Revenue is an amount. So how much revenue did my firm earn last year? Cost, expenses are an amount. So what were my expenses? I didn't list it on this slide, but another variable is a balance. So a balance is a difference between amounts. So a variable like profit is a balance. So we're going to take the difference between two amounts, revenues less expenses, to get to profit. So those are the basic terms. At this point, you should attempt this restaurant survey. So this is a survey that we're going to be making a lot of use of this quarter. A few years ago, we did a project for California Pizza Kitchen, and they gave us the data and the survey form that they'd executed in their restaurants over a certain period of time. And so I've been using this as a class example ever since. So this is the exact survey that they gave us. Your task is to identify what types of variables are these. Are these nominal? Are they counts? Are they dichotomous? And sometimes multiple terms will apply to the same variable. The answers are given to you down below in the footnote. All right, that's it for this first lecture in chapter 2.